So this is a radio review, actually a transceiver review. This is a radio that I've seen advertised quite a bit, but I haven't really seen much reviews of this radio. And there was one YouTube of somebody doing some testing of one. I couldn't follow anything he was doing. There was no audio. So anyway, it's a very curious radio. It's a dual bander, but it has a GPS receiver in it. So that's kind of interesting. And it has a large display, large color display. So it's an interesting radio. It's beefier than a Baofeng, and it's got a bigger battery. There's a lot of things about it that are more robust than your normal radio from China. Now this is from a company called Abbree. And so that's the first thing that makes this radio kind of odd. You don't see this brand very much, Abbree. Now you say, oh, I've seen that brand before, and it's due to these antennas that you see for sale, these kind of bend over antennas, and they have the Abbree logo on them. And so I thought Abbree was just an antenna manufacturer. But it turns out that they have a brand where they sell radios. So let's kind of take a look at that first. It's a little confusing who the parent company is. In China, a lot of times it's difficult to figure out who owns what, who does what. So they built all kinds of radios under the Abbree names. There's a tri-bander. This is the one we'll be looking at. This is the AR-F8. And six band radio, 1,000 channels, color display, frequency detection. It's very, very interesting, and GPS. That's kind of its weirdness factor is this GPS, north latitude, east longitude, and altitude. So we'll take a look at that. But they have a bunch of Abbree radios. All kinds of them, and kind of searching around, it seems as though there is a parent company that builds a lot of radios in China. And so this particular manufacturer not only builds the Abbree radio, but they build the Baofeng radio, and they build the Wuzhen radio, Wushan, maybe it's Wushan radio. And so they have a lot of brands, and on their website they claim that their master brand is Abbree. And these are all HTTP www.abbree.cn, China. So yeah, it's a little bit of a this radio is a little bit of a mystery. But let's take a look at what you get. Okay, so first of all, full disclosure, I asked Banggood to send me this radio, and so it was comped to me, and they sent me this in exchange for a review, and so let's do the review and see if we can find out more about this strange radio. It's got a strange antenna too on it, so we'll test that out as well. Okay, so this is the box it comes in. Hello. And I don't read any Chinese. There's probably more information here about the actual manufacturer. But what you get is you get a nice English manual. You get a great drop-in charger. And the thing that's been bothering me about Japanese radios, I recently bought a Yaesu radio, and it doesn't come with a drop-in charger. You got to pay extra for that. It's ridiculous. All the Baofengs come with it. All the Chinese radios come with it. You have to buy it extra on the darn Yaesu. The Yaesu is a better radio, but come on, it's a drop-in charger. Everybody wants a drop-in charger, and it comes with a little clip. And a little wristband. And my Yaesu radio did not come with a wristband. That just really irked me. They wouldn't even throw in a stupid little wristband. I had to go dig one up. Anyway, so that's what it comes in the thing. So let's turn this thing on and see what it does. So like I said, the battery's pretty big. It's about 1 centimeter thick, and it says it's 880 milliamp hours. 7.4 volt, and the drop-in charger connections. Now the radio itself says something about 20 watts, so makes you believe that maybe it's a high wattage radio. And we'll take a look at the data sheet. But it is giving the 6 bands here. And yes, Abbree does have FCC licensing and stuff. So, yep, go figure. All right, let's go ahead and turn this one on. So to turn it up, so there's 2 knobs. There's a clicky knob here that goes round and round and round for like channel selection. It's a little bit longer than this one. And then this is the power. Okay, take a look at the antenna. I have it sitting here, and it's obviously a dual band antenna. This is a sweep from 100 megahertz to 500 megahertz. This is S11, and so it definitely is working at 144 and 440. So let's zoom in a bit here. I've already saved a setting. So I have a floppy disk where I can save things. And I have the 2 meter band here, recall state. So it automatically, you can store settings and stuff and bring them back in. So this is 144 to 148. And you can see the SWR here. So it's definitely below 2 most of the time. And then interesting observation is if you're building antennas that are meant to be handheld, then your head is next to the antenna. And if you put your head next to the antenna, look at what happens to the SWR. It gets better. So, you know, are these antenna designers that clever? Yeah, they might be. So they're designed to have some amount of capacitance around the antenna, and then things work better. So it's just an interesting observation, I thought, that these things actually might actually be designed to be used on HT. So let's go ahead and take a look at 440 and see how that's doing. All right, let's do frequency start at 420 megahertz, stop at 450 megahertz. And yeah, there we go. Very nice. So the antenna is obviously dual band, and it's actually working very, very nice at 440, and works good at 220. So I mean at 2 meters. So yeah, it's pretty nice. It's a pretty nice antenna. It's kind of strange in shape. It's flattened in one direction. I don't know if that's just cosmetic or it actually is a PC board antenna. I really don't know, but yeah, the antenna is designed really well. Not as susceptible to having your head around it at 440. Okay, let's do a transmit test first. Push the TX button on the test set here, and I will connect the cable up to the antenna. And just a reminder, this is not a spectrum analyzer. This is a radio test set. It's capable of having 60 watts put into it. It has a built-in attenuator, so don't do this with a spectrum analyzer or tiny SA or anything like that. There's other ways to do that, and we'll do that a little bit later. So let's turn the radio on. I will go to Vfo mode. And so right now the display is showing 145. What's it showing? 145.525 is what it's set to. It doesn't really matter. So I'm going to go ahead and push the transmit button and see how we do here. So 145.525, so frequency is on. It's giving us 3.8 watts. And let's go to Let's see. Let's see if it transmits touch tones. It sounds like it does. Let's turn up the volume here. Input for FM demodulation. How come I'm not hearing anything? Hello, test. Oh. It is modulating. Hello, test, test. So it's modulating. It's not outputting any touch tones when I hit the front panel. So anyway, it did modulate. I didn't hear anything though. Hello, test. Hello, oh, there it goes. Hello, test. Testing 1, 2, 3. Test, test, test. All right, so turn that down. So it is working. Our transmit power is quite low though. That's on 2 meters. Let's go to 440. Let's do 444. Let's do 444. How about that? 000. Oops. Okay, let's transmit there. So 444.00000, 3.5 watts. So once again, a little bit low in wattage. Let's see here. Let's go to the bottom end of the band. We'll go to 440.000. We're getting 3.4 watts. And I don't have a fully charged battery. It's half charged right now, so that might be part of the problem. So let me do that. Let's give it a full charge. We'll come back, try it out, and see if the power increases. We can do a receive sensitivity test though. We'll go over here to receive. We've got our sine ad up and running. What we need to do is we need to input the the earphone jack. I need to insert the earphone jack in so that the audio comes out of the radio and goes into the test set. And then I can turn on the frequency here, which is 440 megahertz right now. And let's see if we can get a tone out. And we are getting a tone out. Let me unplug the earphone thing. So we are getting a tone out, and we can turn this way down, and then you can start to hear there's a little bit of noise on the signal now. So we will plug that into the sine ad measurement. Usually it's a sine ad of 12, so we can lower it down until this number comes down to around 12. It's probably maybe somewhere in there. It's a bit noisy. And we can set the amplitude to microvolts. So 0.14 microvolts of 12 dB sine ad is actually quite respectable. So yeah, I wouldn't have expected anything else. All these radios are built off all the same chipsets, so they're going to measure basically all the same. So let's give it a full charge and see if we can't do better here. Let's increase the amplitude a little bit. Yeah, 0.2 volt, 2.2 microvolts. We're getting a really, really good sine ad. All right. So yeah, let's charge it up. Give it another try. Okay, so while we're waiting for the battery to fully charge, let's take a look at the specs for this radio. 50 ohms. It says it's 8 watts, so they claim this radio has 8 watts of RF output power. I question that highly, but we will see after a full charge. FM modulation. Spurious is... their spurious is very interesting. It is not a relative emission, it is an absolute emission. So the units are in dBm. That's very, very interesting, because I think that is the latest way to measure spurious emissions from the FCC. Minus 36 dBm. And I don't recall if that is the correct number or not. I want to say minus 43 dBm is what the spec says, but I'm not versed in the spec. But it is encouraging, though, that they're giving numbers in dBms, so we can measure those with the spectrum analyzer. They give different specs. They say that the spurs are less than minus 36 dBm, less than a gigahertz, and greater than a gigahertz, they're at minus 30 dBm. So that's very interesting. Transmission current, receive sensitivity. So we just measured the SINAD. Yeah, it was a 12 dB SINAD, and the receiver sensitivity is 0.25 microvolts, and we measured 0.14 microvolts. So they're definitely beating the spec there. There's an intermodulation and rejection spec of 55 dB. Conducted spurious emissions of less than 57 dB. So yeah, anyway, so I think the most interesting specs are going to be output power. Is it really 8 watts or not? And then we'll try to do a spurious test here on the spectrum analyzer and see what we measure. All right, as far as one of the reasons I like these new radios is that they have a very wide reception. So if you're not going to use these things to transmit on, you're mostly listening, you can buy one of these things without a license if you're just going to listen. And the frequency range is quite large on this unit. Let's see if I can get back. It. Here we go. So I know this is way too small for you guys to read. Frequency range 65 to 108 megahertz. So it will receive FM broadcast stations like the Baofangs do. 136 to 174, 175 to 220, 230 to 250, 330 to 350, 350 to 400, and 400 to 520. So it does have a nice selection. Unfortunately, the only modulation it understands is FM, okay? So one of the reasons I enjoy other radios like my Yaesu is that it allows the aviation bands. Aviation bands are AM modulation. This does not include the AM band to begin, the FM. This one does not include the aircraft bands to begin with, and if it did, it probably wouldn't be able to receive them anyway. So one of the interesting things about this radio is out of the box, it has transmission open everywhere. You can transmit on all of these frequencies, which is not legal to do. So please don't do that. And in fact, in the user's manual, it says, please don't do that. It's illegal. There is no diode declip. There is no Mars modification. It does transmit on all these frequencies, including things like MERS and FRS and things like that, but it is definitely not legal to do, and the book says it is definitely not legal to do, so yeah, don't do that. All right, it's been overnight and I've charged up the radio to its maximum, so we will see how it does on the transmit test, how many watts this thing can output. And let's turn it on. 8.1 volts. So the battery is at 8.1 volts. And we are going to transmit on 450 megahertz. And there we are, 450, and we're getting 5 watts out now. So there you go, the battery was low. So we're getting 5 watts out, certainly not the spec, which is 8 watts. That was not right. So let's put in, let's say, 145,000. Oops. All right, let's see how it does at 10 meters. And a little bit less, 4.12 at 145. So there you go. So it's a 4 or 5 watt radio. Definitely not an 8 watt radio. So the next test to do would be the emissions test. Look at for spurs. And yeah, let's go over, take a look at that. I'll put in a couple pictures here that I found online showing the actual PC board in this thing. You can see that it's got a pretty nice layout. There's a microprocessor at the bottom and a PLL, and then there's 2 separate channels for UHF, VHF, and a bunch of receive channels, and then you can see the filtering on the antenna. So it's actually quite a nice design. All right, so let's try out 440. So we'll do a frequency start of 400 megahertz, and we'll let it run up to 1.8 gigahertz. And I will hook up the radio. I'm hooking it up with a attenuator, of course. I have a 30 dB 5 watt attenuator, so that will handle the 8 watts we've got. And let me get that. Let me get the SMA connector tight here. There we go. All right, so I've got my 30 dB 5 watt pad on here. Let's tell the spectrum analyzer that we have a 30 dB pad. Reference offset of 30. So now all the measurements will be referenced to 30 dB. And so let's go back and put it at 4. Let's see. I want to go to this one. 4. Let's say 45000. There we go. And there we go. We're getting spikes. So let me put the amplitude reference level at +10. All right. For some reason, I had to enter the 30 dB again as a reference. I guess I didn't push a button or anything. So anyway, the peak search is happening at 36.37 dBm. So let me convert that. 36.37 is 4.33 watts. So that's about what we got on the other machine. And we do have one little spike down here. So we will do a search on him. And he's happening at minus 18.74 dBm. Now the specifications said minus 36 dBm, and so it certainly isn't meeting the specification. So let's do another measurement. Let's do peak search. We'll do a delta marker. And so we're down minus 55 dB from the peak down, so it's down minus 55 dB. So as far as an absolute, I think that's a pretty good number. As far as, as a relative, that's a pretty good number. As far as an absolute, I think it's high if you believe their data sheet, or it just might be a typo. It might just mean they meant minus 36 and they're at minus 55. So I'm not sure. The size of that spike is not too much different than my Yaesu FT3D. So, it's in the ballpark of being a good radio. Let's go ahead and try 2 meters. So let's go to 1. Oops. Getting used to this radio. There we go. So let's do 14500. Okay, so let's set up the spectrum analyzer. We'll do a frequency start at 100 megahertz, and we'll do a stop frequency at 500 megahertz. And let's see how that looks. Oh, that looks good. Ooh, These are much, much bigger. That's not good. All right, so let's do a single trigger. And trigger on that. Okay. So peak search gives us, oops. Oh, I have the delta marker on. Let me turn the delta marker on. There we go. Normal marker. Yeah, there we go. Peak search. Okay, now we're at 35.78 dB, plus 35.78 dBm. So that sounds right. Let's type that in. 35.78 gives us 3.78 watts. Sounds about right. The thing that's disturbing though is that second peak there. So let's do marker peak search. We'll do a delta marker and search right. So it's only minus 39 dB down. So at 2 meters, it's failing. It's definitely failing at 2 meters. Yeah. So I would say that the filtering is pretty poor at 2 meters and looks reasonable at 440. So there you go. Certainly don't meet the absolute numbers. And I would say this radio is fine at 440. I think it would meet all specifications at 440 just fine. And but at 2 meters, its filter is just not up to snuff. All right, so final impressions of the radio. Build construction is very, very good. It's a heavy radio. It's got a big battery in it. It only outputs 5 watts, but that's fine for most things. Size-wise, in comparison, here's an FT3D, and they're fairly comparable in size and in weight, in thickness. This one might be a little bit thicker. But they're neither one of them is a small radio. They're nice in the hand. The antenna is very good on it. It does have 1,000 programmable channels. You can program it with chirp. You do need the adapter cable. It uses the same adapter cable as a Baofeng, just the microphone earphone input type of thing. Whereas the Yaesu you had to buy a special cable for. The Yaesu you had to buy a drop-in charger for. The Yaesu didn't come with a strap. A lot of things about the Yaesu I don't like. But the radio itself is awesome. So they are not comparable radios. The GPS function on the Abbree is a little bit of a joke. Yes, it has a GPS in it. And yes, it will tell you your latitude, longitude, and your elevation, just the straight numbers out of the GPS. But it's not going to do you much good, right? It doesn't have APRS like a radio like this. So there's really not much you can do with that information other than maybe if you're lost in the woods and you make contact, you could give people your exact location. So that would probably be the only use case for the GPS function. They could have spent more time on the graphics and made this radio look super, super expensive, but they used really cheap fonts and didn't spend any time on the user interface and stuff. So it could be made into a really, really nice radio. No, it doesn't pass specifications for FCC. And what else is there to know? It is priced quite reasonable. I'll put a link down below if you actually do want to buy one of these things. Yeah, like I said, comes with all the accessories, and there you go.